Hello, everybody. Day 2 of chapter 16, and actually the last of the instruction that we'll be doing for this particular chapter. We have some things to talk about with means and variances. So way back in the day, chapter 4, we learned a couple things talking about center and spread when we have to add or subtract constants. So adding or subtracting a constant from a random variable shifts the mean, but does not change the variance of the standard deviation. So I want you to recall that when we have a pen that works, when we have a distribution, any kind of distribution, and we were to add 5 to everything in that distribution, all it does is it shifts that distribution over. So if I added 5 to everything here, the distribution should look the same. That one definitely does not look the same. That one looks better. Should look the same, but shifted to the right by 5. So there's your plus 5 right there. So the center changes. It moves the same amount that you added everything to, plus 5. But the variance, the spread, did not change. And that holds true for probability models as well. If I know the expected value of a distribution, if I were to add plus 5 to everything in that distribution, I simply add plus 5 to the expected value, and that's my solution. For the variance, adding a constant does not influence the variance. So an example of something like this might be if we added 5,000 to everybody's salary. Okay, so adding a constant changes the mean, but does not change the variance. Same idea. When multiplying each value of a random variable by a constant, it multiplies the mean by that constant and the variance by the square of that constant. Now that is different than what we had before. Before it was we just multiply it by that constant. When we're talking about a probability model, we multiply it by the square of that constant. So e of x, when we multiply it by a constant, we simply take the expected value and multiply it by that constant. For the variance, when we multiply that constant, we multiply by the square of that constant. And that will give us what the new variance will be. And again, an example of this would be everybody in our company receives a 10% increase in salary. That means that our constant would be 1.1, and we would multiply that by the expected value or the average value of salaries, and that would give us the new average salary. And the variance, we'd be multiplying by 1.1 squared times whatever the variance is, and that would give us the new variance. Last rule, in general, the mean of the sum of two random variables is the sum of the means. The mean of the difference of two random variables is the difference of the means. So in general, if I were to take two different random variables, let's say I had two different companies, and I wanted to find out what the average would be if I added those two companies together, I simply take the average of the two companies and I add them together. Subtracting, if it's the difference between them, if I want to know which company pays more on average, I take the average of each of them and I subtract them instead of adding them. Okay? So that's if I have two different random variables. However, for the variance, first of all, we can only do this calculation if these random variables are independent of each other. So in the case of the two companies, the wages of one company couldn't influence the wages of the other. As long as that's true, we can calculate this. If we can't, then we can't even calculate the variance. Okay? The variance of their sum or difference is always the sum. So it doesn't matter if we're adding or subtracting, the variance always increases. If I'm taking two different companies and adding them together, the variance increases, the amount of spread increases. If I'm taking two different companies and I'm subtracting them, the variance still increases. So addition or subtraction, I'm always going to increase the two variances. Let's do some problems. Let's take that dice game that we played in class today. If we were to add 10 points to each result, what would the new e of x and standard deviation of x be? Okay, so we found that the e of x was 10 and the standard deviation of x was 18.03. So if I were to add 10 points to everything, what would the result that I get be? Well, e of x plus a is a plus e of x. So that means that if I were to take the average, which is 10, and add 10 to that, my new average would be 20. What about my standard deviation? Well, variance of x plus a was simply equal to the variance of x. Now notice that this rule talks about the variance, not the standard deviation. If I'm going to do any calculations, I need to first take the standard deviation and turn it into the variance. Now, it's not going to make a difference this time because no matter what we're doing, if we're adding, variance doesn't change. So what's the standard deviation? Standard deviation of x plus a is not changing. It's still 18.03. What if, instead of adding 10 to each one, we were multiplying each point by 4? Again, originals were 10 and 18.3. What would that be? Well, e of a times x is simply a times e of x. So this is going to be 4 times 10 for 40. Variance, on the other hand, is different. It's the variance of a times x equals, what is this? This is the variance, a squared times the variance of x. So we do have to do some calculations here. First of all, we need to turn this standard deviation into the variance. And I will remind you that the standard deviation of x is the square root of the variance of x, which means that the variance of x is the standard deviation of x squared. So I need to take 18.03 squared. So what's the variance of x in this case? Let's grab my handy dandy calculadora, and we're going to square that, and we get 325.0809. So what's my solution down here? It's a squared. My constant is 4, so this is 16 times 325.0809, which is 325.0809, which is 5,201.2944. Big ol' ugly number. Now that's the variance of x, of a times x. What I need is the standard deviation, so I need to take the square root of that. So the square root of that is square root 5,201.2944 is 72.12. Which in this case, technically, if we're just multiplying by 4, we would actually get that number. But that's not always true. So, multiplying for the variance, we need to do a bit more, right? We need to go to our variance, we need to multiply by the square of that, and then convert around. Okay? Let's do one more example together here. We found that e of x is equal to 10, and standard deviation of x is 18.03. If we were to allow 2 people to play, meaning I've got 2 people playing the game, what would the average and standard deviation of their combined score be? Their combined score, in other words, what we're trying to find is what is e of x plus y and the standard deviation of x plus y. Well, our rule says e of x plus y is simply e of x plus e of y. So if I have two people playing this game and I'm combining their score, I'm taking the two averages and adding them together. So e of x plus y would be equal to 20. The standard deviation, on the other hand, got to do a little bit more. Because remember, the standard deviation of x plus y, that's the variance of x plus the variance of x. And then to find the standard deviation, I have to do the square root of that. So we need to convert to the variance, which we did on that previous problem. It was 325 point something. 325.0809. So this is going to be the square root of 325.0809 plus 325.0809. And I'm going to do that on my calculadora and take the square roots, and I'm going to get 25.498. So the mean when adding two together, I simply take e of x plus e of y, it equals 20, 10 plus 10. For the standard deviation, I have to convert them to variances. I have to add the two variances together, take the square root, I get 25.498. Last thing. Oops, I have some weird things there. Last thing. What if we wanted to find the expected value and standard deviation of the difference this time between two people's scores? In other words, find e of x minus y and standard deviation of x minus y. So, e of x minus y, from our rule, when we have two random variables, to find what their difference would be, I simply take the two averages and I subtract them. In this case, that's 10 minus 10 equals 0. Average score will be 0. Our variance rule, the variance of x minus y, variances always add. So the variance of x minus y is still the variance of x plus the variance of y. And then, of course, if we're finding the standard deviation, we need to take the square root of that. However, what that means is the standard deviation of x minus y is the same as the standard deviation of x plus y. So we have already calculated this. It's 25.498. Because standard deviations, variances, when we're combining two random variables, always add. So it's going to be the same answer. Okay. So tomorrow in class, what we're going to do is we're going to start out, we're going to do this car dealer problem. It's the last page of your notes. And then we'll have some more time to do a variety of problems on Thursday and Friday. Okay. We will see you tomorrow. Bye.